Okay.
Come back to me.
So really quick, we know that we may have to use implicit differentiation anytime that we have an equation that has x's and y's all jumbled together with exponents, and it's not in y equals form. It's a candidate for implicit diff. It doesn't mean it has to be done like that, right? Only, obviously, if you're trying to find its derivative. A couple of the things you'll need for the AP Calculus exam is to be able to find the derivative implicitly, and also to find points on a curve with particular slopes. So like I mentioned earlier, when we have a horizontal tangent line, the slope is equal to what? 0. And when we have vertical tangent lines, we know the slopes are undefined. And we kind of talked about when a fraction is equal to 0 and when a fraction is undefined, right? So when is a fraction equal to 0? Only when the numerator is equal to 0, and when is a fraction undefined? When the denominator is equal to 0. So awesome. So we kind of did some of those examples on the previous lesson. Today we're going to do problems where they actually give you a particular slope. So they'll say, find the points on the curve where the slope is 1/2. So now you're not equaling it, the numerator or the denominator to a value, you're actually equaling it to 1/2. Or whatever the slope is that they give you. And the last thing is anything that they could ask you to do with a regular derivative, okay, they could also ask you to do with one that you found implicit. So like finding where it's increasing or where it's decreasing, finding maximums, finding minimums, all those fun stuff. Okay? Cool? Alright, so accidentally when I made this a copy, I printed it out and it came out in color. So the graph that I had here was in red, really light red. So when it ran off the copy, for some reason the red part didn't come out. Okay? But it's a wonderful thing that it didn't, because now we can share this moment talking about how to graph this on the calculator, right? Cool? So that's why, you know, I just take things the way they come, right? So I think it was meant to be. It was a blessing in disguise, some would say. Okay? Cool? So let's go to the calculator, and these wonderful TI Inspirers actually have the ability to graph this exactly the way you see it. You don't have to even make it y equals. So go to the graph app and open it, and let's type in this equation. Anybody know how to do that?
Yeah.
Yes, all you have to do is press delete to take off the equals, and then you go all the way down to where it says relation. Okay, so we're going to enter a relation. We're not entering a function anymore. Okay, because this will not be the graph of a function. So put in x squared plus 4y squared equals 16. This is not the equation of a circle. This is actually the equation of, anybody know the shape of that? An ellipse. Very good. Okay, if we had a circle, these two values here would be the same. This would have been 4 and this would have been 4, then it would have been a circle. Okay, but since they're not, it's an ellipse. There's also something called a hyperbola. Have you heard of that?
Yeah.
Hyperbola, and what's the other one? A parabola? Yeah? You ever heard of a parabola? Yeah?
Never.
What's that?
Never heard of a parabola? It happens. So you have parabolas, the ones that look like
Why
this,
is it a
right?
perfect circle?
I know, like my circle doesn't look like.
This is not a circle.
Yeah, I messed up.
This is an ellipse, right?
Mine is a circle.
Or should it be a circle?
Yeah, fix it.
Okay, cool. Anyways, but that's a conversation for us to have at another time. So let's go ahead and graph it as best as we can. Right, we want to make it a nice football that's full of air, not deflated like the Patriots use. Okay? The Cowboys, you know, Dak, he likes his football to be firm and, you know, full of air. Okay? Anyways, so let's find a couple of points that we could possibly use to help us draw it, right? Like these endpoints. So 0, 4. So it goes all the way to 4. It's actually 4, 0. Okay? And how about the other one over here on this side?
-4.
-4, 0. And the other one would be 0, 2, and 0, negative.
I'm scared to do the circle because I know
Mine's
it's
meant to
really
be like-
bad.
It's not a circle.
It's
It is.
It's
Whatever.
It's an oval.
Whatever. Whatever.
It's just an oval.
Wow.
It's an oval.
It's gotta be something.
Just try your best.
They're all from the same.
I'm not really good at doing this either.
Yeah.
Wasn't it at one? No, it's a square.
Is that two?
It wasn't true.
It's like not like this.
No, he gets a Squidward, that's
Mine looks like an eye.
Okay, interesting.
Yes.
Alright, so we're good?
No.
So this is the picture that should have been there.
Okay, yeah.
I missed already.
Looks like a lemon, yes. Later on when we start talking about integration and we do, we're gonna do a volume, so we're gonna start like rotating a particular curve about the axis. And you're gonna imagine it three-dimensionally, so it's, yeah, rotating about the axis. And it'll create a shape of a lemon, like we call it a lemon drop. Have you ever had one of those candies?
Yeah.
Yeah. I'll bring some lemon drops, so on that day we can eat those candies. Okay, and then another day we'll do Hershey's Kisses. It'll be really cool. Anyways. Finally, bring the food back, right? We had the pineapple, we had all this fun stuff. That was just like to hook you to stay in calculus, right?
What is it?
And here am I still hopeful
The
that
gummy bears, you know?
No,
Yeah,
I
it was
have
like-
a note for you.
Welcome to calculus. Alright, anyways. So, the first part says to use implicit diff to find the derivative. So let's do it. What's the derivative of this guy? 2x plus derivative of this guy. 8y dy dx equals 0. And now we have to make it dy dx equals.
Can I just do it in one thing?
You can. Can you do it all in one thingy?
Yes, we
Yeah.
can.
You can? Not all of you are geniuses? Okay, I'll show the steps. So 8y dy dx equals negative 2x. Divide by the 8y. So dy dx equals, what's negative 2 over 4? I mean, negative 2 over 8.
The shot of my voice is
So negative x over 4y. That was easy, right?
of course.
Okay, on the AP test, they won't give you one that easy, right? They'll probably give you one that has product rule or quotient rule, or they'll probably ask you to do the second derivative where you do have to do something.
How do you
But that is one of the skills that you need to be able to have. Cool? Alright, the second thing that we need to talk about, or we've already talked about, was finding the derivative, or finding the points where we have particular slopes. Okay, so where would I have a horizontal tangent? Again, this is only if my derivative is a quotient of two variable expressions, meaning that it's a fraction, right? And the numerator and the denominator both have variables in them. Okay, so if I find the derivative like I did here, and the numerator and the denominator both have variables like this one does, then all of these things are true. Okay, if I wanted a horizontal tangent, it's going to occur where the derivative is equal to what? dy dx equals to 0, right? And when is the fraction equal to 0 again? When the numerator of dy dx is equal to 0, right? We're going to have vertical tangents when the derivative is undefined, right? If I have something divided by 0, that's undefined, right? And that's going to happen when the denominator of that derivative is equal to 0. Because the denominator, or because the derivative was a fraction, right? Cool? And if we were to ever end up plugging in a point and we were to end up with 0 over 0, okay, that would mean that there would be no tangent line at that particular point. So what would that imply? There could be a hole, right? So there may be some discontinuity, right? Okay, there could also be a what? Of vertical asymptotes. How did we find vertical asymptotes when we were talking about just the original function? And it was a fraction. It was where the denominator was equal to 0, right? And how did we find holes when we had the original function? The common factors, right? Whatever would cancel out, would be my goal.
Let's see the greatest common factor.
Pretty good? Yes? So we're gonna practice this skill, we're gonna do some examples of this, and this is exactly what you needed to do for those questions on the previous assignment, number 5 and 6. Okay? So after we do these examples, you could go back and do those later on tonight. Turn it over to the back. Okay, I didn't write the equations that were on the front side here, so just put them at the top for me. So the original equation was x squared plus 4y squared equals 16. And we already found the derivative, so let's write that down because we're going to need it. So dy dx equals
Almost like rewriting the whole work and
negative x over 4y, right? We're not going to do all the work again because we already have it, right? But let's look at this question. It says find the points. Points meaning that it's an x and a what? And a y on the curve at which there are horizontal tangents. So when will I have horizontal tangents? It, what is it? When the derivative is equal to 0. Okay? So that's why step A says set dy dx equal to what? To 0. So we're going to say negative x over 4y equals 0. And when will that be equal to 0?
When x equals 0.
Only when the numerator is equal to 0, right? So all we have to do is say negative x equals to 0, and we're going to solve for x or for y, in this case for x. So I get x equals to 0, right? Now that's only the x part of the point, I need the y part. So it says substitute the x or y value into the original equation. So get this number and put it back in. So 0 squared plus 4y squared equals 16. This guy goes away. What can I divide by? By 4. Y squared equals 4. Square root. Y equals plus or minus 2. So where will I have horizontal tangent lines? What will be my points? It's not just at one point, there's actually 2 of them. 0, 2, 0, negative 2. Is that true? Yes? How can I prove it to myself? Look at the graph, right? Do we have the graph of it? Yeah, we drew it on the other side. So let's turn it over and let's see if for sure at these 2 points we have a horizontal tangent. Okay? Even though it's all bad. Okay? So if I were to come along on this ellipse with imaginary tangent lines, as I got close to 0, 2, would I have a horizontal one? Yes. And if I kept going and going and going, and as I got close to 0, negative 2, would I also have a horizontal tangent? Very good. So we did it mathematically, and now we're looking at it visually just to double check our answers. But that's what it is that you're finding. Okay? Pretty cool? Alright. So now let's do the other one. Okay? And this one's another easy one. So it says find the points, again, x's and y's, on the curve at which there are vertical tangents. So this is where the derivative is what? Undefined. Okay? So where will negative x over 4y equal undefined? That's going to happen only when what part of it is equal to 0? Only when the denominator 4y is equal to 0. Denominator of dy dx equals to 0. What will y be? Okay. And what do I do with that 0? Plug it in, because I only know the y, I need the x's. So let's plug it in. So we got x squared plus 4 times 0 squared equals 16. That goes away. X squared equals 16. Square root, square root. What's the square root of 16? Plus or minus 4. So these are the easy problems. Where do I have a vertical tangent line? -4, 0, and +4, 0. So can we get a visual inspection and check on our graph to see if that is true? Yeah. Should be true, right? We didn't mess up. Let's double check. So if I go to 4, 0, would I draw a vertical tangent line there? Oh, yes, sir. That's good. That wasn't a sneeze. Was that a fart? How about at -4, 0? Would I also have a vertical tangent line? Yes. Forgive me if I'm not as energetic as I usually am. I seem to be coming down with something.
Me too.
Okay? I'll try my best to put on a good show.
Watch video.
Remember, this is my acting job. Jennifer's my director. She's actually the one that knows the calculus. I'm just pretending to know it.
I'm also pretending.
Good? Alright, so now let's look at the other example that we mentioned to where we don't want to know where the slope is 0 or undefined, but we want to know where the slope